Class, in this video we are going to start cross product, which is also named as a vector product. In the previous lecture we have discussed about the dot product, which is also named as a scalar product, and now we are discussing about the cross product. So the product of the two vectors a and b, if you're talking about the cross product, it is represented with a cross b, and its resultant or its answer is basically a cross b is equal to a into b sine of theta unit vector u or unit vector n. So basically a and b are the two vectors magnitude, that is the magnitude of a and the magnitude of b, sine of theta, and then the unit vector along with it. So sine theta, for theta lying between 0 to pi, as we have discussed previously, that why we are imposing the conditions to be from 0 to pi, the same reason is over here, because sine theta is a periodic function. And now the direction, as we are talking about the cross product or the vector product, it means we must need to mention a direction as well. So whenever we are having a cross product, the direction of the resultant vector is always finded with the help of right hand rule, we all know about. So how we can find out the direction of a cross b, because the magnitude is going to be a into b into sine of theta, but the direction is really very important, and for the direction we have to follow the right handed rule or the right hand system. So according to right hand rule, if we are rotating our fingers in the direction of the product, that is, this is the direction of A, and here we are having, this is the direction of vector A and this is the direction of vector B, and we want to find out the direction of A cross B, it means we will rotate our fingers from A to B. So if we are rotating our fingers from A to B, the direction of the thumb is going to represent the direction of A cross B. Clearly, if I rotate the fingers from B to A, it is going to be in the downward direction. So here you can also see that if this is my vector A and this is my vector B, and I am placing my right hand in the direction of A, so if for A cross B, I'm just rotating my fingers from A to B, and the direction of thumb is representing the direction of A cross B. And on the other side, if I'm going to rotate my fingers from B to A for B cross A, so if I'm rotating my fingers from B to A, it means my direction of the thumb is going to represent the direction of B cross A, which is now in the downward direction. So clearly, when we are talking about A cross B and B cross A, their magnitudes will be the same, but the direction will be opposite. That's why we always say that A cross B is equal to minus times of B cross A. That is, they are having the same magnitude, but their direction is going to be opposite. Next, we have some rules or properties for the cross product. Number one, A cross B is equal to minus times of B cross A. Then we have A cross B plus C is equal to A cross B plus A cross A, that either you add the vectors first and then take the cross product, or you take the cross product separately and then add the vectors. The answer will be the same. The same one we have already discussed for dot product, that if we are taking a scalar multiplication of A cross B, then it is possible that you can multiply the scalar with any one of the vectors first, and then you multiply the cross product, or you take the cross product of the two vectors. Then we have I cross I, J cross J, K cross K. Clearly this must be 0, because I cross I will be equal to the magnitude of I into magnitude of I into sine of 0 degree, because the angle between I and I is 0. So sine 0 is 0, that's why we are going to have 0. So I cross I, J cross J, K cross K is always 0. But for I cross J, we are going to follow the right hand rule, and according to right hand rule, we are going to have the unit vector K. So x, y, j and k are the rectangular vectors that always follow the right hand rule. According to this, whenever we are going to the product of I and j, or I cross j, we are going to have the vector k, and for j cross I, obviously we are going to have minus k, that is the negative of this vector. For j cross I, for j cross k, we are going to have I, and for I k cross j, we are going to have minus I, obviously the negative direction. Then for k cross I, we are going to have j, and for I cross k, we will have j. So it means we have to follow this circle, that is from I to j and k. So if we are following this circle, we can easily write down the products over here. Next we have, if a1 is a1 I cap plus a2 j cap plus a3 k cap, and b is equal to the vector b1 I cap plus b2 j cap plus b3 k cap, then their cross product is represented as the determinant of this vector, this matrix. So as we have discussed previously for dot product as well, that whenever we are having the two vectors with the components, then we can find out their dot product with the help of the formula that we are just multiplying the corresponding components and then adding, that is a1 plus b1, a1 b1 plus a2 b2 plus a3 b3. And for cross product, we are saying that we are going to solve this determinant or the matrix determinant of this matrix. So we are going to prove it as well. So here you can see that in question number 27 we are having the same question, that we are given with two vectors a and b, and we have to show that their cross product can be defined with the help of this determinant. So a cross b by definition is going to be this simple product a and b, and we are taking the cross product. So we are going to simplify it as a1 cross product, as we have discussed that a cross b plus c is equal to a cross b plus a cross c. So we are going to imply this one. So a cross b is equal to a, so this is going to be first one multiplied with the whole, that is a1 I cap cross product with b, similarly a2 j cap cross product with b plus a3 k cap cross product with the b vector, and then we are going to separate it again, I cross I cross j, and I cross k. So I cross I is simply 0, I cross j is k, and I cross k is simply minus j. So I am going to replace it over here. So I can do one extra step as well. So this is going to be 0, this is going to be 0, and this is going to be 0 as well. a1 b I cross j is k, so here you have a1 b2, and then I cross k is minus j, so here you have minus j. Then j cross I is k, here you have a2 b1 minus k, and then you are just replacing this I cross j, I cross k, and j cross k, k cross I by with I j and k, or minus I minus j or minus k, as the components are going to be, or as the resultants are going to be. And then you can see that this is basically the determinant of I j and k, a1 b, a1 a2 a3 b1 b2 b3. So simply we are replacing the values of I cross j, I cross k, j cross I, and then we are taking the common components over here. The next property is saying that the magnitude of a cross b is the same as the area of a parallelogram with sides a and b. So here we are going to prove it in question number 30, that the area of parallelogram with side a and b is basically the a cross b, magnitude of a cross b. So we know that the area of a parallelogram is simply base into height. So base is the magnitude of vector b, and here is the height h that we have to find out. So I'm just drawing a perpendicular over here. So this is a right triangle with angle theta. So I can find out the points of this, or the coordinates of this point, that is a cos theta and a sin theta. So I'm just going to replace the height with a sin theta, and the base is the magnitude of b. So magnitude of a into magnitude of b into sine of theta is basically the magnitude of a cross b. This is what we have to prove, that the magnitude of a cross b is the area of parallelogram with sides a and b. The next property is saying that if a and b are the two non-zero vectors or non-null vectors, and their cross product is a zero vector, then what will you say about a and b? So if we are saying that the cross product of a and b is a zero vector, it means a magnitude into b magnitude into sine of theta into unit vector n must be a zero vector. So a is a non-zero vector, b is a non-zero vector, n is a unit vector. So it means sine of theta must be equal to 0. So if sine theta is equal to 0, it means theta is equal to 0 or 180 degree. It means these are parallel or anti-parallel. So whenever the cross product of two non-zero vectors is 0, we will say that the two vectors are collinear vectors. We cannot say that these are parallel, we will say that these are collinear vectors, because these could be parallel or anti-parallel as well. Now we will discuss some questions related to the cross product. Question number 21, we have already discussed about it, that a cross b will be equal to minus times of b cross a, because it has the same magnitude but its direction is going to be opposite of a cross b. Then a cross b is equal to the 0 vector. If a and b are not 0, then show that a is parallel to b. So we have already discussed about it as well. Then we have question number 23. Show that a cross b whole square plus a dot b whole square is equal to a square plus b square, magnitude is square. So a cross b whole square plus a dot b whole square. A cross b is a into b into sine of theta unit vector u, who magnitude square, and a dot b is simply a into b into cos of theta. So when I'm going to take the magnitude, this is going to be 1, that is this u will be removed by 1, and we will have a square b square sine square theta plus a square b square cos square theta, which is simply the squares of the magnitudes. So a square into b square. Then we have question number 24. We have already discussed about these, that I cross j will be equal to kj, because we have to follow this cycle like I, j and k. So I cross j is going to be k, j cross k is going to be I, k cross I is going to be j, j cross j is 0, we have already discussed. I cross k and minus times of k cross I cross k, because it is opposite to the circle or the cycle, so we have to replace it with minus times of j. Similarly, I cross I is 0, and when we have to solve this one, 2j cross 3k. So as we are having two different, and j cross k is going to be I, so we are going to have 6i. Then we have 3i minus 2k, so 3 into 2 is minus 6, minus 2 is minus 6, and we have to solve I cross k. So I cross k is opposite to the cycle, so we will replace it with minus j, and minus minus plus is going to be plus 6j. So this is how we can solve the products over here. Question number 25 is not a part of your course. Question number 26 is not included. We have already discussed question number 27. Then we have question number 28. We are given with the two vectors a and b, and we have to find out a cross b, b cross a, and a plus b cross a minus b. So for a cross b, we have discussed that we can find out a cross b if we are given with the components by solving the determinant. So we are just solving it with the help of this determinant. So a cross b is basically ijk, 2 minus 3 minus 1, the components of a and the components of b. So we will solve this determinant I as it is, and we will expand it with the first row, minus 3 minus 1 4 into minus 2, and then minus j, 2 into minus 1 1, and minus 2. So we are just opening this determinant, and we will get the final answer for this. Or you can use this method as well, but obviously this method is quite simple and easy as compared to the second one. Similarly, you can solve the other two vectors, that is b cross a, and you can see that a cross b and b cross a are having the same components but are in opposite direction, that is all the components are negative now. Then you have to find out a plus b cross a minus b. So for this we will find out a plus b and a minus b, and then we will take the cross product by solving the determinant over here. Then we have question number 29, and you have to solve this question by your own, because we have to solve it for a cross b cross c and a cross b cross a. So clearly we have to solve a cross b first, and then we will take the cross product with the vector c as we solved over here. Similarly, in this one we have to take cross product of b and c first, and then we will take the cross product with a as shown over here. Then we have question number 30, which we have already discussed about. Question number 31, you have to solve question number 31 by your own, and if you have any problem you can ask me. Then we have question number 32. Determine a unit vector perpendicular to the plane of A and B. So as we have discussed that the unit vector perpendicular to the A and B is simply the cross product of A and B. So we are taking the cross product of A and B, and then for unit vector we will divide this vector by its magnitude as done over here. So it means that now there are three methods to solve such a question in which we have to find out a vector perpendicular to the plane of A and B. Number one, as we have discussed in chapter number 1, that we can take the so you can solve it by the previous method or this method as well, that we can simply take the cross product of a and b and then take the unit vector, find out the unit vector corresponding to that. You have to attempt question number 33 by your own, and if you have any problem you can ask me further.